find out. Probably have one of you guys tell me at the end, try to pull it up and see it. Part of this goes over that page that you've already done, 133, so that's going to be part of it. And then the other part is the next section. So there'll be two sections put together. Precision and accuracy of measures. Precision is the repeatability or reproducibility, sorry I can't say big words, of a measurement. It depends only on the smallest unit of measure available on a measuring tool. If I'm looking at this, if this is my measuring tool, watch closely on this because this is what matters. You'll notice here, my spaces are split up into how many degrees? 5. So that's as close as I can get. If I come up with an angle and it's coming like right here, right in between this, then I'm going to have to round it off to either 30 or 35. One of those two. Okay, and that's what this is saying. When you're looking at a ruler or something, different rulers will have, different setups. So you might have a ruler and it might have something on it like this, maybe it's inches, and it might only be split up into that. Well, then the closest we can get, the most precise we can get on this is to within 1/2 of an inch. If I do this, now we can be a little more precise. We can get to within what? What would that be if I separated those two? Instead of 1/2 inches, now we could go down to 1/4 of an inch. All right, and if I put another one in there, now we're at what? 1/8 of an inch and a 1/16 of an inch, and we could keep going. And that's what it's saying. The precision depends on the smallest unit on the measuring tool. So if the smallest unit is 1/8 of an inch, then that means we can be precise to within that 1/8 of an inch. Okay? So that's what precision is. Again, precision, I got written out there. Make sure you fill it in. I'm not going to read it again. I just read it up here. I'm not sure why I put it on there twice. But accuracy. Accuracy is the nearness of a measurement to the true value of the measurement. You've got to know that these two are different. Precision and accuracy, two different things. Precision, and I'm going to show you here in a minute, but precision is, are you getting right there, that same spot every time? Right? And I probably shouldn't be using something like this, but since we do live in Preble County, if you're shooting a gun and it has a scope on it, and you're trying to sight in that scope, if that gun's shooting the same place every time, you're being precise, but does that necessarily mean that you're being accurate? No. All right, so if I'm shooting that gun and I'm sighting in this scope, and it's hitting the NT flag over there every time, and I'm trying to shoot old Godfried up there on my wall, if it's hitting the same spots, or close to the same spot every time, I'm being accurate, I'm not being precise. Or it's the other way around. I'm sorry, I did say it wrong. I thought about it as soon as I said it. I'm being precise, but I'm not being accurate. So two different things. Joseph has missed me not being here, and not being able to correct me when I screw up. The length to the nearest centimeter. If I look at this, and it's on your paper there, you'll notice there's no marks in between. There's no marks in between, so the closest I can get is the nearest centimeter on this to measure with. All of these three segments that I have here, if I was going to measure them, how much would this first one measure? 8 centimeters. How much would the second one measure? 8 centimeters. How much would the third one measure? 8 centimeters. They all measure the same because that's as precise as I can get using that measuring tool. Put an asterisk beside this where it says precision. This is important. The precision of a measuring tool is 1/2 of the smallest measurement on the instrument. What's of mean in math? Other one. So it means 1/2 times whatever that smallest unit is. That's how you find the precision of a tool. 1/2 times whatever the smallest unit is. What if you don't want to use 1/2? You could use 0.5. All right? And it depends on, if we're doing something in centimeters, we probably want to use 0.5. If we're doing something in inches, we probably want to use the 1/2. Just depends on what we're measuring. So on this example, I look at this is my measuring tool. The smallest unit on this measuring tool is that right there, which is 1/10 or 0.1 of a centimeter. And that's where I got this number from. Well, I times that by 0.5, and it gives me 0.05 centimeters. So I can be precise on this using this measuring tool within 5/100ths of a centimeter. And all that means, if I take something and I'm measuring this segment, say it goes out to there, and Fletcher looks at it and he goes, well, it's closer to that mark than it is to that one. And Maya looks at it and she says, no, it's closer to this one than it is to that one. Neither one of them's wrong, all right? So what we do with that is we can only be precise to within that. So I look at it and it goes 1.9 maybe, if we're looking at Fletcher, what he said, and Maya looks like maybe 1.8. Am I going to mark either one of those answers wrong? No, because with the tool that we have, that's the best measurement we can get. All right? On this one, the smallest, this is a normal ruler here. How many spaces are there in between 1 and 2 on a normal ruler? 16. So that's 1/16 of an inch times 1/2, which means we can get to within 1/32 of an inch to the actual measure. That's how precise we can be. Now, you guys have done this already because you've rounded stuff off, you looked at stuff, we measured things, and you said, okay, so that goes out to 2 marks, and then you rounded it off. You were already using this, you just didn't know you were using it. Because you were looking at that mark and saying, well, I think it's right here closest to this mark. But you were getting within that certain precision, whatever that certain measurement tool or measuring tool was. All right, so this explains what Joseph just corrected me on a second ago. Can you see those black dots on your paper? That's sort of hard. Can you see them? You might want to darken them in or something. So stop writing for a second and just watch up here so you see this. Difference between accurate and precise. This first one, both accurate and precise. The second one is accurate but not precise. How come? I can't see the dots on mine. Are they all spread out? They're all within this circle here, right? But they're not all right there real close together. So it's accurate, you're hitting your spot, but it's not real precise. Next one says precise but not accurate. Well, what's happening here? They're all in the same spot right there, but Did we hit the spot that we wanted to hit? So we're not very accurate. And then the last one, what's happening there?
They're spread all over the place.
They're sore all over. So we're not real accurate and we're not real precise. All right, fill in what you need to fill in on this next part. Approximate error. Approximate error. In the physical world, measurements are always approximate. You can't measure anything and be exact. There's just absolutely no way. I don't care what. You go home and you get your dad's toolbox and you get out one of those things that looks like this with the little, goes in and out. And as soon as he sees you, he yells at you because you don't mess with that stuff, right? You're not supposed to, because that's what he uses to be precise with, and if you screw it up, then it's, so you're not allowed to mess with those. Joseph doesn't have a clue what I'm talking about on that. You ever leave the house, Joseph, or you just sit in the house?
Absolutely.
So, no, they're, what are they called? Anybody know what they're called?
I thought you left the house up.
But I'm also old, so I forget things real quick. I'll remember it in a minute. So, you can be real precise with that. We can still never, ever be exactly right. Okay? So the approximate error of a measurement can help you determine how accurate your calculations can be using that measurement. A lot of stuff, like if you work for NASA and you were working on, which I know they don't really do it anymore, but the space shuttles and stuff, they got to be real precise. They're probably going to be a lot more precise than we would be if we were building a shed. Okay? So they're going to be more precise. Are they still ever going to be exact? No. But there's certain error that you got to be within. And they know what that error is on the space shuttle when they're putting it all together and making sure that it doesn't get too hot when it gets shot into outer space and everything else. There's a certain amount of error that has to be in there, but they try to keep the error very small, whereas we're probably not going to worry too much if we're building a shed about the how much error there is. So approximate error is the positive difference between the actual measurement and an approximate or estimated measurement. Down here, this is the formula right here, E with the little subscript A. So error, and what's the A stand for, you think?
Approximate.
Approximate. What's these little bars here mean?
Absolute value.
Absolute value. Please make sure you don't forget that. Absolute value. So you're taking the absolute value. You take the actual measurement minus the estimated measurement. You've got to be real careful. If we have something, if I have a scale sitting up here, and I bring Hunter up and we weigh him, he tells us he weighs us whatever, all right? He weighs himself. Which one is the actual measurement?
The weight scale.
The one he told us
Oh.
is the actual. The scale is our estimated measurement. All right? Now, I know that doesn't seem to make a whole lot of sense, right? But let's change it, because you guys don't think it makes sense because we let Hunter tell us something and you're thinking, no, that can't be the actual, that can't be right. We're going to go by the scale, not by what he says. You go to the store and you buy a pound of hamburger. You take it home and you weigh it. Which one's the actual measurement?
The packaging.
1 pound. All right, what we bought. And what's our estimated measurement? Whatever we weighed it at. All right. So here, an example I have. You weigh a 10-pound bowling ball. Right away, what do we know about that 10 pounds? That's the actual. and it weighed at 10.15 pounds. That's your estimated. So we subtract those two. What's 10 minus 10.15? Close. Negative 0.15, right? And then you have to take the what? Absolute value. Right? Because we don't, when we're dealing with error, we don't care if we're too low or too high. We just know it's error. Right? It's just not right. So that's why we take the absolute value. So the approximate error for this is 0.15 pounds. Students often believe that the measurement with the most decimals is the actual measurement. Is that the case? No. The actual measurement is what you're starting with, what it's supposed to be. All right? When using measurements to calculate a greater approximate error will have a greater effect on the accuracy of the results. So in other words, the more error you have, the worse your measurement is. Measurement error may also be due to rounding. We have this problem a lot with students. You guys round too much. You don't round correctly. And that's one of the things that we're going to talk about. All right? A lot of times people round stuff off just to make it easy on themselves. That's not the way it works. Oops. What I want to do. Not what I want to do. When rounding to a place value, look at the value immediately to the right. Hopefully most of you know this. What's the rule when you're rounding?
5 or greater, round it up.
5 or greater, you round up.
4 below.
4 below, you just cut it off. It's called truncating. All right? You don't round down, you truncate it. That means you cut it off at that place value. So this that I have up here, round 42.64 to the nearest 10. What number do we look at to decide how to round here?
4.
The 4. What's that second 4 tell us to do? Just cut it off right there. So it ends up being 42.6. What if it said round it off to the nearest whole number?
Round it up to.
Then we look at the 6, and what's it tell us to do? Round it up to 43. What if it told us to round it to the nearest tens? T-E-N-S, tens. We look at the 2. Now, do we cut it off here? This is a little different. What do we put behind it?
0.
A 0. All right, so we'd round it. We would round this off, we'd round off to just 40. Do we really need the other stuff behind the decimal? And when I say cut it off, usually we have a decimal and that's where we're rounding stuff, right? So that's when we're cutting stuff off. That's when we're normally rounding. Range when rounding. This you got to listen to closely. Make sure you understand this because this is probably one of the most important things that we're doing today. Your range when you're rounding something. That last one, we rounded 42.64. We rounded it off to 42.6. What's that telling the next person that looks at it? Is it telling them that it's exactly 42.6? Because we can't be exact. All right? So what you got to know is that's telling that next person that the actual length, because Fletcher might not be able to measure the greatest in the world, but he can get within a certain amount and we can rely on that. So the actual, whatever the actual measurement, we know since Fletcher gave us this number, has to be between two things. If we're looking at a ruler, and I'm not going to try to draw a ruler with 42.6. If we got 42 here, our segment comes out to somewhere close to 42.6. Does that mean it's exactly 42.6? No. What two numbers is it going to be? We know for sure it's between. Now's where we're going to use what we said before about the precision. If we went out to 0.6, that means we're taking 0.1, that's the smallest unit of measurement we have on our measuring tool, times, what are we timesing it by every time? 0.5, or 1/2. And that's 0.05. To find this range, all you're going to do is you subtract off that precision number and how are you going to find the high side? Add it on. So you subtract off the precision number and add on the precision number. So if I got 42.6 and my precision number is 0.05, if I subtract off, what do I end up with? What's 42.6 minus 0.05? 42.55. What if I add on the 0.05? So going back to Fletcher, we don't think Fletcher's number is exactly correct, but we know, because he can measure well enough, that the actual measurement of that segment or whatever he was measuring is going to be between 42.55 and 42.65. Does that make sense? Wouldn't that make any sense? You wouldn't lie to me, would you? Many students believe that numbers can be rounded twice. Oops, I put this in the wrong spot. That's supposed to go down there.
I just wrote it down.
So you see what I just did? See what? You can't handle that? Joey, hop up there and draw him an arrow. I don't know why he can't handle it, but. Many students believe that numbers can be rounded twice. Don't do that. If we have 7.45 and they want you to round it to the nearest whole number, is that going to round to 8? What's it going to round to? 7, because all we look at is the 4 there. All right, so don't round it twice. Don't say, well, that rounds that number up, so that's 7.5, then we're going to round that up. Don't do it twice. On this example, sorry, I have the answer in the wrong spot. This the 9.5 and stuff is supposed to go down here for the carpeting example. I have to fix that. Alejandro wants to carpet his bedroom. He measures the dimensions of his bedroom and rounds to the nearest foot. The carpet he chose cost $2.63 per square foot. When Alejandro measured this, said he went to the nearest foot. So do we know for sure that the length of his room here is 10 feet? What's it between?
9.5 and
So we can go a half a foot one way or half a foot the other way, right? We know we don't think he's an idiot, and he measured 10 foot and it's actually 15 feet. So we know that, hey, it's somewhere in between 9.5 feet, 10.5 feet. We think that he's measuring good enough. His width, he measured the width at 8 feet. So what's it got to be between? 7.5 and 8.5. How do you find the area of his room? What shape is it? Really? So what's the area, what's the formula for area of a rectangle? Length times width, base times height, whichever one you want to use. So the lowest amount of carpet, or the least amount of carpet that he could need, would be a length of 9.5 times a width of 7.5. And that comes out to be 71.25 feet squared. How would we find the most area, or the most carpet he would need? 10.5 is the length, 8.5 as the width. And that comes out to be 89.25 feet squared. So we don't know exactly what the area is. And I just got done dealing with this because my wife had hardwood floors put in our house here a while back. So I just got done dealing with this. We had 4 different people come in and give us estimates. They all measured it. Not a one of them came up anywhere close to the other 3. So all their areas were all completely different. And they were all using those lasers and stuff, holding it up, and they're supposed to measure exactly. So none of them were close. And I had to call them all back and say, all right, I got one person who got 980 some square feet. Another one of you got 700 and some square feet. Another one got 800 and some square feet. They were all ranged out like that. I said, if you want this job, you need to come back and measure it again. And I went ahead and measured it and figured out what it should actually be, and seeing how close they were to what I got. And that's who we went with, was who was actually closest to doing it right, instead of just going in there and hoping they're close and then charge us for a bunch. Which didn't work out real well, because we still got 2 extra boxes of the hardwood flooring that we paid, probably $100 each for or something. So,
Well, now you ever have to redo it.
for real. Once we know this is the area, could we figure out the cost? How would we figure out the cost? You might want to get out your calculator and help me.
Multiply 89.25 times $2.60.
So 89.25 times what?
$2.63.
$2.63. What is that?
234.73. I rounded it up.
So $234.73. Is that? So we're sure that that's going to be the cost of Alejandro putting down this carpet?
Sure.
No, that's the what?
Estimate.
That's the highest. That's the highest it should be. What else do we still need to find?
Lowest.
The lowest. How can we find the lowest?
71.25 times 2.63.
So 71.25 square feet times $2.63. What's that give us?
187.39. That's rounded to.
And that's the lowest amount that Alejandro could pay. So Alejandro probably wants to make sure that the bill, when he gets it, is in between about $187 and $235. Somewhere around in there is about where it should be. So if they come up and they tell him the bill's $300, what should he do?
No.
You should say, hold on now, something's not right here. Did you multiply right? You might want to figure it out. Significant figures, or significant digits. You guys done this in science class yet? Significant figures? I know they do it in science class, but I don't know when. Fill in what you need to fill in on that.
One of those weird boys in the background of the rap video.
I'm not so Slim Shady.
No, you're Slim Shad.
Yeah, right. So using significant figures allows us to maintain the correct level of precision when you're working with measurements. Sorry, I'm not an English teacher. I'm not supposed to be a Paul. Significant figures or significant digits. I know in science class they say like sig figs or whatever when you have it in there. Of a number are the digits that are used to express a measure to the appropriate degree of accuracy. The stuff that we're doing right now, we're going to do this a little bit with it, then probably for the rest of the year, you want to use your brain to round stuff off and to make sure that you're doing stuff correctly and not just go by every one of these rules. Reporting that the measurement of segment AB is 4 centimeters. So if I tell you AB is 4 centimeters, do we know for sure that that's exactly right? We actually know that it's not exactly right because nobody can measure exactly. So saying something is 4 centimeters is less precise than telling that same segment AB is 4.1 centimeters. When you're looking at significant digits or significant figures, the rules, non-zero digits are always significant. So anything that's a number other than 0 counts to be significant. In whole numbers, zeros are significant if they fall between a non-zero number and a digit. In other words, like this 0 here in 5,078, that 0 counts as significant. All right? In decimal numbers, greater than or equal to 1, so when you have a number in front of the decimal, every digit is significant. So if I look at this, 7.60, there's 3 significant digits there. All 3 of those count as significant. Now a lot of people will say, well, in 7.60, that 0 doesn't really do anything. And you're sort of right. If you dropped off at 0, I probably wouldn't throw a fit. But if Damon leaves that 0 on there, that's telling the next person that looks at his number that he was precise to within 7.6. Sorry, I had to think for a second. 7.595 to 7.605. If he drops the 0 off, Then it looks like he was precise to 7.55 to 7.65. So with the 0 on there, we're given a more precise measurement. We're telling the next person that looks at it, hey, I went out to the hundredths place. And that's where I rounded it off at. So I was being more precise than just one decimal place. In decimal numbers less than 1, so when there's no whole number in front of the decimal, the first non-zero digit and every digit to the right are significant. So in this case, what they're saying there is we got 0.029. The 0 that's out in front of the decimal means nothing. All right, does anybody know why we put a 0 in front of the decimal? What happens when we do this? And I just put .029.
It's words in front of it. It could look like a period.
A lot of times that decimal gets lost, right? We've already seen it when I've had people come up right on the board and you do this. Then Sam wasn't paying attention, so she looks up here and she goes, oh, 85. Because you can't hardly see the decimal, right? Does anybody know why we put a 0 in front? The only reason is that thing that you grabbed out a few minutes ago to do the multiplication and stuff for me, the calculator. Because on a calculator, you put that 0 in front so that whoever looks at it goes, oh, there's a decimal there. If you didn't have that 0 in front, that decimal would get lost all the time on the calculator. So with this, they're saying this, the 0 out in front of the decimal is not significant. They're saying the 0 behind the decimal isn't significant either. That part I really don't agree with when they do all this stuff. Because does that 0 behind the decimal actually mean something? Yeah. So why it's not significant, I'm not sure. But I don't really agree with that. And this is one of the things, like I was saying, when we go to round stuff off, you're smart enough, you're going to round stuff off correctly, even if you say, oh, there's 3 significant figures here instead of 2. We already did this. Just looking at this real quick though, each one of these segments is how long? How long is the first segment?
6.
6 centimeters. How long is the second?
6.
6 centimeters. How long is the third one?
6.
Because we can't be any more precise than that. Notice that the exact length of each segment is above 5.5 and below 6.5. So that's how precise we're being. The range of the measurement is equal to the approximate length plus or minus 1/2 units. We already did that. Thus, the length of each segment has 2 significant figures. So there's 2 significant figures here. Find these examples, we'll do them together. Maya got too used to me not being here, and now she's bored. She'd rather just be doing the work, right? So on these examples, find the possible range for the length. First thing you need to do, and that's what I've done up above the ruler here. On this first ruler, it's in inches. What's each little section stand for on this ruler? 1/4 of an inch. That's where the 1/4 came from. So I take 1/4 times 1/2, and I get 1/8. So again, we're saying that if we're using this, we're going to be precise to within 1/8 of an inch. Well, then our range, we're going to take our actual measurement. It looks like it goes out 1.5 inches. Does that look right? 1.5 inches. Everybody agree with that? I can't hardly see it up here. So 1.5 inches. So we're going to take 1.5 inches and we're going to subtract off 1/8 of an inch. That's going to give us the low side. Anybody know what's 1.5 minus 8? How many eighths are there in a half? So 4/8. 1 and 4/8 minus 1/8. What does that give us? 1 and 3/8. That's the low side. 2, if we add 1/8 to that, what's that give us? So 1 and 5/8. That's the range. Again, if we go back to Fletcher, Fletcher told us that the measurement is 1.5. We sort of believe Fletcher, but we don't think that he's exact, so we know that the measurement is between 1 and 3/8 and 1 and 5/8. Same idea on the next one, centimeters. What's the smallest measurement on this centimeter ruler? 1/10 of a centimeter, because there's 10 little spaces in there, right? So 1/10 of a centimeter. So we take 0.1 times 0.5, that gives us 0.05. Somebody measure that for me, because again, I can't see it very well up here. 2.2?
Yeah.
Is that pretty close? What's 2.2 minus 0.05? 2.15? That's the lowest it could be. What's 2.2 plus 0.05? 2.25. So the range has to be between 2.15 centimeters and 2.25 centimeters. All right, dealing with the significant digits or significant figures. When you're using addition or subtraction, a calculation can not have more digits to the right of the decimal, that's behind the decimal, than either of the original two numbers. So all they're saying there is you take the number, when you're deciding how to round something off, you take the number that has the fewest numbers behind the decimal. So looking at my two numbers here, 73.654 and 45.1. That tells me how many places am I going to put behind my decimal in my answer. It can't have more than either one of the two original. So it's got to have the same as which one? The one. So it's going to have how many places behind the decimal? One place. So I get this answer, 118.754. Well, what am I going to round that off to? 118.8. Because the 45.1 only had one place behind the decimal, so that's what we want our answer to be. Again, as we go through and we do this, if you round your answer off to 2 decimal places, you think I'm going to throw a big fit? Probably not. Unless this is what I'm looking at, that you know this rule. All right? But otherwise, as the year goes along, probably not throwing a big fit. Multiplication and division. When using multiplication or division, the number of significant figures in the final product or quotient, so in your answer, is determined by the original number that has the fewest numbers of figures. How many significant figures in this number? I think I did this one wrong. How many significant numbers or significant figures in this first number? 6.18. 3. How many in 4.509? Be careful. It's only got 3, because again, what do they not do with that 0? They don't count, right? I don't agree with that, but so it says, let's read it again. When multiplying and dividing, the final product quotient is determined by the original number that has the fewest. What was the fewest? 3, right? So when we round this off, I rounded it off to the hundreds, 27.86. I actually counted how many significant figures? 4. The answer probably should be, the actual answer should probably be only using 3 significant figures. What would it be rounded off to 3 significant figures? 27.9. So you might want to write that down. The actual answer is probably 27.9 because it's 3. Again, am I going to throw a big fit if you round it that way? Probably not, because I think that's better. The way I think that rounding should be done, and it doesn't really matter what I think, but the way I believe it should be done, if this one has 2 places behind the decimal, this one has 3, then you should probably round off to at least 2 places. And keep at least 2 places. That way you're staying consistent all the way through whatever the problem is. Part A, find each measurement rounded to the correct number of significant figures. How many significant figures in this first 837.24? 5. How many in the 276.516? So if we're subtracting, what did it say to do subtracting so I don't have to go all the way back? It said to do what?
Using additional subtraction to calculate or have more digits, the right decimal than either of the first numbers.
So we want to do it so that it has no more than, oh, it says to the right. So this one had how many places to the right? 2. This one had 3, so we want to round it off to no more than 2 places. So I did my subtraction here, 837.24 minus 276.516, and I got 560.724. What am I going to round that off to?
560.72.
So we're going to go out to the hundredths place to round it off. What I do here, Fletcher, because I got 4 1/4 there. What I do when I went to find the area, changed it to a what? Decimal. All right. So you should be able to do that. I changed it to a decimal just to make it easier. Because if you have a decimal, you can put it where? In your calculator. So to find the area of a rectangle, what's the formula for area of a rectangle again? Base times height, length times width, either one works. So I multiply these, 4.25 times 2.5. How many significant places or significant figures in 4.25?
After the decimal or all together?
All together. How many? 3. How many in 2.5?
2.
So our rule said that we want to round it off to 2 significant figures. So if we're doing significant figures, we do this multiplication, 10.625. What's that round off to if we just want 2 significant figures?
10.
If we just want 2 significant figures,
11.
it's just round off to 11. I think that's too much rounded. That's the way significant figures is telling you to do it, round it off to 11 inches squared. I think that's too much. But if that's the rule that we're using, then that's what it needs to be. A better answer might be something like 10 and 5/8 inches squared, or to round it off to one place behind the decimal, which is 10.6 inches squared. Again, I can teach you all this stuff about sig figs and all the rounding and stuff. A lot of times it's just common sense, knowing, hey, how do I want to round this off? All right? If I'm boring out the cylinder on the cylinders on my car so that I can make the motor have more power, do I want to be real precise or not real precise? You want to be real precise. If I'm cutting a board, making a picture frame, do I want to be real precise or do I not have to be real precise? Maybe sort of in between, right? Because you want them to match up well. If I'm building a shed and I'm cutting the board off, do I have to be real precise or not real precise? Not real precise. If you ever watch anybody build anything, it seems like you want them to be precise, right? When you go across 8 foot, any contractor or construction person will tell you, across 8 foot, you can be up to an inch off. So if I had to cut an 8-foot board and I cut it 7 foot 11 inches, that's close enough. If I cut it 8 foot 1 inches, that's close enough. That's what they go by. It's about that much. Next one, a flower garden. The world's second largest flower garden is, I'm not even going to try to pronounce that. That sounds good. Park in the Netherlands. I'm not sure how to pronounce that name either. The Netherlands, which covers 79 acres and contains 7 million flower bulbs. About 30 gardeners work together each year to design the flower formations. How many bulbs do they use in each square yard of the garden? Round to the correct number of significant figures. Anybody know this here? 1 acre is about how many square yards? 4,840. Did you know that before you read it on there? Don't lie to me, Joe. You knew that? That's pretty good. So 4,840 square yards. Sam, you don't believe me?
He shook it. He smiled as if he would. There's no way.
Let's do this before I go on and do the answer here. If I have an acre, because that probably 4,840 yards squared makes no sense. Fletcher couldn't go home and measure off an acre of land. All right? If I know it's 4,840 yards squared, what could I do to get a measurement for the length and the width to actually make sense to the normal person? Not the Mr. Swiharts of the world that have been doing, planting stuff their whole lives and know exactly how many acres are in this little lot, this little lot, this little lot. So if I had 1 square yard, this was 1 yard square. How many feet wide is it? 3? 1? Half? Which one is it? What's a yard? How many feet's in a yard? 3. So how wide is it? It's 3 feet wide, right? How long is it? It's 1 square yard. So it's 1 yard by 1 yard. 3. How many square feet are in that 1 square yard? Count them.
1, 2, 3, 4, 5, 6, 7, 8.
So 9 square feet. 1 yard squared equals 9 feet squared. What could we do to this number to make it into feet then?
Multiply that by 3.
Divide it by,
Uh,
so somebody help me out, what's 4840 divided by 9?
537.7.
So we'll say 538, that's gonna be close enough, right? So it's 538 square feet. Well, if I take a square, how many feet wide is it gonna be?
About 538.
About 538. How many feet long is it gonna be?
About 538.
So Fletcher goes home, and he goes out and he measures out in his yard a square that's 538 by 538. What does he have?
Too much free time.
1 acre.
1 acre. Fletcher might not think that way when he's buying a piece of property and the guy rips him off.
Nothing's already done by.
Tells him it's 10 acres, and then later on down the road, when he tries to sell it, he figures out there's only like 7 there.
That's swindle.
Got ripped off.
So on this, to do this problem, we take, and we didn't need to have all that, but we take 7 million bulbs, there's 7 million flower bulbs, divided by the 79 acres. Somebody help me out, what's 7 million divided by 79?
88,607.595.
88,607 point something, 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 right? So that means that each acre contains about 88,607 88,607 flower bulbs in each acre. Well, they didn't want to know how much each acre contained. They wanted to know how much each square yard contained. So a 3 by 3 box. How many bulbs are in this 3 by 3 box? That's what they wanted to know. So all you do is you take that answer and divide it by 4,840 square yards. And what's that give us?
Well, your answer gave 18.3.
Yours did?
Actually,
That's all right. So 18.30735. We want to round this off to significant figures. What's significant here? What are we looking for here? What are we trying to find? How many what? Bulbs per square yard. So we got this 3 by 3 square, and we're trying to figure out how many flower bulbs are in that 3 by 3 square. So what's significant there? Are we going to put down 18.30735? Just 18, because we're just looking at how many bulbs. How many bulbs are there? About 18 bulbs in that 3 by 3 little area. Cycling. Jim is preparing for a 50-mile cycling race. How many significant figures in this 50?
1,
2.
2?
I thought they only counted the.
Now remember, if it's in front of the decimal, everything counts. How many in the 19.7? She cycles an average of 19.7 miles per hour. How long will it take, Gemma, to complete the race? Round your answer to the correct sig figs. So we said the significant figures in the answer can't be more than the one that has the most. So which one of these two has the most?
19.7.
So how many places do we want? We want 3 places. So I divided 50 by 19.7, and I got 2.54 something, 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 something. But I rounded it off to 2.54 because How many significant figures does 2.54 have? 3 places. 3 significant figures. The radius of a circle has a measurement shown. Somebody tell me, what is this measurement shown here?
7.5.
7.5. Anybody else agree with that? Now, Lily said 7.5. Does that mean it's exactly 7.5? No. What could it be? Be careful now.
Well, it's 7.5.
Remember, we take away, what's the smallest measurement here? 0.1, right? Times 0.05, or times 0.5, sorry.
7.45 and then 7.5.
So even though she said it's 7.5, it could be anywhere from 7.45 to 7.55. What's the formula for area of a circle? Anybody remember that from before I was out?
Isn't it
Pi times radius squared. Well, we're saying that the radius is anywhere from 7.45 to 7.55. So the first thing I did was I stuck in 7.45 for the radius. And I ended up with this. Make sure I did it right. Pi times 7.45 squared. Is that correct?
5 times 7.5
Calculator's getting on.
squared. 176.714.
Did I mess it up? Pi times 7.45 squared. I hope I didn't mess it up. It's going to look bad, Joe, if I messed it up.
174.366246.
So we round that off to 0.37. Is that all right? Yeah. What are you going to do to find the other area? That's the lowest it could get. What's the highest? How could we find it?
5 times 7.55.
Pi times 7.55 squared. Try that. See if you come up with what I got.
179.2786.
Should I round off to 0.08?
Yes.
Did I round it to the correct significant figures? Probably not. How many significant figures did we have in our measurements? 3. So we probably should have rounded it off to how many places? 3. So instead of 174.37, what should this have rounded to?
174.
Just 174. I don't, again, I don't agree with that. I don't know why you'd round it off that much. What should this one round to? 179. But if that's the question I'm asking you and you round them off that way, can I really throw a big fit? Because that would be the correct answer as far as its significant figures go. Right. On this assignment, page 133 you should already have, right?
Yes.
So that should already be done. Add this to it, page 143. I was hoping we have some time, but we don't really have a whole lot. Page 143, 1 through 43, the odd numbers. Just the odd numbers. Which numbers are the odd numbers?
1, 3, 5,
7.
9.
I think you can remember that.
Yes.
Please make sure any of the homework, 04 is right here. Please make sure any of the homework that you might have that is not turned into me gets into here. If you don't have it today, check on Moodle, see what you're missing. I'm not going to listen to anybody whine and cry next week. Check on Moodle, see what you're missing, get it into me tomorrow or early next week. Does everybody understand that? No ifs, ands, or buts, right? Because I'm not going to beg again. Yeah, you can just turn it. I don't care about being stapled. All I care about is it's got your name on it and the page number. So any of those pages, what was it, like page 81, page 91, page 103, 113, I guess they're right up there, aren't they? And page 125. They're all over there on the board. If you don't have them, get them. Make sure you get them into me. What else is due next week?
Binders.
Your binder, please make sure. If you don't have a binder, there's some binders up here. You can grab one. You can also grab a divider if you need dividers.
Somebody put this on there. I don't know who it is. Damn,
I totally got hold of that.
Hey, George.
I was literally about to pass it.
Love you, man. Love you too. Be safe out there.
Boy, don't worry about it.
Streets of Indy or
Yeah, do me a favor, please put your chairs up. If nobody's sitting in the seat there close to you, put up the chairs around you.
Don't we have to wipe them off?
Yeah, we should, but that's all right. We'll still might be sitting in them for like 18 hours, so.
It'll rub itself off.
COVID bugs supposed to die after like 10 hours or something. If it,
on metal, it's faster than that, and then surfaces, like other metal, it's about that.
it's supposed to be on stuff like cardboard, it lasts for like 24 hours. But this stuff doesn't last that long, so it should be all right.
I know, like you're gonna slap me.
Thank you. Make sure you get stuff in.
If I sit down,
George, did you see it?
I can sit down and I can fall asleep without lying down.
Damon, you can fall asleep as always, regardless.
I think it's not what I said it last week.
Like,
No.
give me a thumbs up or that fucking
What?
When you fell, I thought you fell asleep on us.
The only bad thing is, you think it's funny,
What?
and I'm worried about your grade.
Oh, sick.
Falling asleep is not really helping you in this class.
pretty good.
I did it.
Dude, I couldn't worry about you. I was laughing too hard.
Why were you laughing?
Well, Kean hurt his finger, and then he got hit in the balls, and then you fell to the floor randomly.
Okay. Yeah, I kicked the ball and
I didn't see that. I was still facing Kean, and then I just hear him bang, and then he's on the floor. Yeah.
Oh yeah, you were gold. I can't get over that. That's so